Hello all, in this video we are going to learn hill climbing algorithm. So climbing algorithm is a heuristic search algorithm used in artificial intelligence for mathematical optimization problems. It continuously moves in the direction of increasing or decreasing value of an objective function to find the peak, that is a maximum, or a value that is a minimum value. Key features: it is a local search algorithm. It starts with an arbitrary solution and iteratively makes a small changes to improve it. It stops when no further improvement is possible. There are three types of hill climbing algorithm. Simple hill climbing. It selects the first move that improves the current state. Steepest ascent hill climbing. It evaluates all possible moves and chooses the best one. Stochastic hill climbing, it chooses randomly among improving moves. There are three drawbacks of the hill climbing algorithm. First one, that is a local maxima, may get stuck at a peak that is not the global maximum. Second drawback, that is a plateau, that is a flat area where no improvement is seen, causing the algorithm to stop. And the third drawback is reaches. It is difficult for the algorithm to navigate a narrow path. So this is what the diagram for hill climbing algorithm. You can start at the initial state. You will climb the hill, and whenever there is a flat area, you have to stop. That flat area is nothing but a plateau. Or when there is a smaller peak, you again can stop, because then you will think you have reached your goal, that is a local maxima. But you can see at there is a global maxima, that is the goal that you have to reach. But because of these obstacles, you cannot reach it. So that's a hill climbing algorithm. We always have to move from the starting point to the goal point, and in between there can be three things which are present, that is local maxima, plateau, or ridges, because of which we cannot climb the top of the hill. Example, suppose an AI is trying to train a robot to climb a mountain. At each step, it chooses a higher point, that is a better solution. However, it may reach a small hill, that is a local maxima, instead of a tallest mountain, which is the global maxima. Stop at a flat area, that is a plateau, without any progress. So these are the steps of the hill climbing algorithm. So we'll start with the initial state, that is a random solution. It evaluates the current state using a heuristic, or you can say objective function. Generate neighbors, that are the possible next states from the current state. It selects the neighbor with the best evaluation, that is higher value for maximization or lower value for minimization. It moves to this neighbor state, and it will repeat the step number 2 to 5 until one of the following occurs. No better neighbors exist, so that is a local maxima or plateau reach. A solution satisfying the goal is found, and the maximum number of steps, that is the iteration limit, is reached. That time we have to stop. Let us check the example of hill climbing for solving a number puzzle, that is a 8 puzzle problem. So steepest ascent hill climbing, that is always move to the neighbor with the best heuristic on a sample 8 puzzle instance using a Manhattan distance, that is a lower is better as the heuristic. So you can see this is the 8 puzzle game. We have the initial state given. 8 puzzle game means we have 9 tiles with the 8 number. 0 indicates it's a blank tile, and there will be a goal given. From the initial state, we have to reach to the goal state. So using hill climbing, how we can achieve it, that we have to check. So over here, we will be using a Manhattan distance to find the H value. H stands for heuristic. So H value we can calculate just by counting the number of tiles which are not at a proper place. So just by seeing the initial state, you will get an idea. 1 is not at the proper place, 2 is not at the proper place, then 3 is not at the proper place, and 6 is not at the proper place. Proper place means initial state and goal state, if they are matching, they are at the proper place. Not proper means initial state and the goal state are not matching. So let us check step by step the hill climbing trace. So we will start with the heuristic as 4. At 4 places it is not matching. So H will be 4. We have 0 tile which we can use for moving up or down or left or right. So you can see 1 we have shifted to 0. That is 0, you can say 0 we have shifted to 1 either of the way. So because of which 1 is present at the first tile, and because of which we will get the heuristic as 3. Next you can see the 0 again we have placed in place of 2. So now we have 1, 2, 0 in our first row, because of which now we have a heuristic as 2. Always we have to check whether the heuristic is decreasing, so that at the end we will be getting our goal. Next step you can see the 0 and 3. So 0 is replaced by 3. So now the heuristic will be 1. And at the last step you can check the 0 is replaced by 6. Now our heuristic is 0. That means we have achieved our goal. So this is how step by step, using a hill climbing algorithm, we can solve a number puzzle problem from the initial state up to the goal state. Now let us check the local maxima example in the number puzzle. So again we have an initial state and the goal state given. Over here under initial state you can check H value is 2. H is nothing but the heuristic. How we have calculated it? Using the misplaced tile. So you can see 2 is not at the proper place and 8 is not at the proper place. So 2 tiles are not at the proper place. So that's why the heuristic is 2. And now we will be using a hill climbing algorithm to solve this problem. So using the 0 tile we can do the shifting operation. So 0 we can move up or 0 we can move towards the left. That is the only two things possible. So over here you can see 0 we have shifted up instead of 6. So 0 and 6 are just replaced, or you can say swapped, because of which heuristic coming as 3. Otherwise, the other option is 0 we can replace with 8, because of which again the heuristic is coming as 3. Only that's the two move possible, either up or at the left. We can shift the 0. But because of which the heuristic is coming to 3, which is worse than the previous heuristic, which was 2. So initial heuristic was 2, and because of the movement now we are getting the heuristic as 3, which is worse than the previous one. So hill climbing decision will be the initial value was 2 for heuristic, and all the neighbors are having heuristic greater than or equal to 2. In fact, both the neighbors are having heuristic as 3. So no neighbors improves the H value. So steepest ascent, that is a greedy hill climbing, stop here. So that is nothing but a local maxima. So that is about the hill climbing algorithm. If you like the video, please click on the like button and subscribe. Thank you.